Here we go. In 13.3, your chapter 13 starts taking a turn. And the turn is really going to be, can you take what you did in 13.1 and 13.2 and can you start applying it to word problems? And so if you didn't see the worksheet that I just passed out to you, you have a black and white copy of this gigantic gumball machine. Maybe you've seen one before. One that's so tall that it is 6 feet 10 inches or 79 inches from the bottom to the top. Maybe you've seen one before. Well, they sell them, and they sell them for about $2,500. 1 quarter at a time. It'll pay for itself in, depends how long and where it's at, right? Like how much money will it pay for itself and how much it costs to put it somewhere. Anyhow, if you wanted to buy one of those, it's 7 feet tall roughly. It's guesstimating there, it's 6 feet 10 inches, but they say 7 feet. And then they have this whole ad, and the whole ad says, this gumball machine has a massive globe that can hold, and then they block out how many gumballs that it can actually hold. And then it talks about an inner globe then that can store so many gumballs to save money. Now, some of you may wonder, why would there be an inner globe or an outer globe? Well, what if you want it to look full? What if you didn't want it to like be down here and people may not want to buy a gumball because, oh, that's the bottom of the barrel. It doesn't seem as desirable as a nice full gumball machine, which looks fresh, quote unquote. So here's what I thought. As I was looking at this gigantic word problem, and literally this is what they're asking you to figure out. What's the volume of the gumball machine if the inner globe is not used? They're going to ask you, how many gumballs do you think can fit inside that outer shell? Guess. What do you think the volume of the machine is if the inner globe is used? Figure it out using that information. So literally they're going to ask you a bunch of questions about this gumball machine, and you're going to have to do the math to figure it out. Now, I can't show you everything, but I definitely want to point out some things that you should know. First and foremost, whoever made this machine decided to use an inner globe and an outer globe, or a inner sphere and an outer sphere, so that you could think of all these gumballs being out here to look like it is full. And while you are, let's say, putting quarters in and people are taking gumballs, it takes them out of the inner sphere first, leaving these ones on the outer sphere or something along those lines, to where it doesn't look like the outside is moving down. It looks like the inside, it's coming from the inside. It makes it look more attractive. That's all it really does. Okay, so there's an inner globe and an outer globe. And so you're going to have to do a lot of math to figure out, well, what's the available volume or space between this globe and that globe? There's an inner globe and an outer globe. You are going to be using the sphere formula, which we learned last time as volume is 4/3 pi r cubed. They also give you diameters. If diameters are given, you're going to have to use half the diameter to figure out what the radius is. And you don't just use this formula once, you got to use it like 3 times, so keep that in mind. Okay? So let me highlight some things for you before I give you some time to start it. If you read this whole thing, it's trying to sell you it. It's trying to tell you why you want to spend $2,500. If you were to sell every single gumball for a quarter, I would love to figure out how much money that would be. I will talk to you about it. They did not ask that in the question, but I definitely want to answer that question because some of you are entrepreneurs, which means you guys are business people, and you guys think, well, how much would it cost to actually purchase this, and how much money would it make if I sold every single gumball? That's important for you to know as a business person who wants to make their money back, right? All right. Here are your main things. It measures 79 inches tall. We don't care about that. The reason for that is because that includes this pedestal that the globe is on. There's no gumballs in the red part. The gumballs are only in the part that you see or in the globes. There is a 42-inch diameter. We don't care about that. That is the base. There is a 35-inch outer globe. I want you to circle that. 35-inch outer globe. This is the diameter of the outside globe. There's an inner globe as well. It's 25 inches, and this is a diameter. This is your outer globe. This is your inner globe diameter. Those two things are what you are going to use to figure out what the volume is of the available space. Now, the question that they ask you, which is number 1, which is right underneath that big old thing on your worksheet, it says, what is the volume of the gumball machine if the inner globe is not used? So that just means the outer globe without the inner globe. Let's say everything, the whole minus the inner will equal just the outer. That's what we're going to do. I'm going to take that whole, both globes together, and then I'm going to subtract the volume of the inner globe to figure out what the outer globe's volume is. So let me think about how that would look. If I want to know what the volume of everything is as far as a globe, we're going to use the sphere formula. 4/3 times pi times the radius cubed. The problem with that is that 35 inches is a diameter, it's not the radius. So we need half of 35. Sometimes I use my calculator for that. You can do it as a decimal, or you can leave it as a fraction. It's up to you. It's 17.5 or 35 over 2, same thing. This is going to calculate the volume of the outer globe in terms, and see how this is in inches? In terms of inches. Oh, and I wrote this wrong, didn't I? It's cubed. It's to the 3rd power. Thank you. If you see me make a mistake, please let me know. Because this would make inches cubed, right? This is going to be how many cubic inches are available in that outer globe. Now we need to subtract the inner globes. But that is a diameter, so we need to cut that in half. And you can either use the fraction or you can use the decimal to the 3rd power. And that's going to equal your outer globe's volume in terms of cubic inches. And so as you start this whole worksheet, if you understand what I'm doing here to find out how much just the outer shell is going to be, make sure you're using a calculator to figure this out. I am not going to do this calculation for you. Once you figure that out, they're going to ask you, estimate how many gumballs do you think can fit in there? What's too little? What are too many? What's your first guess going to be? And then they're going to actually ask you, Well, what if the diameter is this? Then plug that in. Figure out what the volume of one gumball is and see how many of those can fit inside your available space. What if you use the inner globe? What would that be? And they're going to ask you a bunch of different questions that go along with it. So, at this point, I'm going to stop your video notes. I'm going to let you do some calculations, and then in about 15 minutes, I'm going to make sure you're on the right track. So 15 minutes, we're going to do part 2 of this video.